Okay, guys, so chapter 12 is very similar to what we have been doing in 10 and 11, um, but instead we're talking about something called a goodness of fit test. And what that means is that we will have two different categories. One will be the observed, what actually happens, and one is the expected. And so, just a quick review about chapter 12. This is from um, the slideshows that you guys all have access to in Canvas. But the requirements, and we're talking about a chi-square goodness of fit test in StatCrunch, there's just two requirements: that all of the expected frequencies have to be greater than 1, and at least 80% of expected frequencies must be greater than or equal to 5. And so that it will ask you that in the first couple questions of this homework. So back to question 5. So with the null and alternative hypothesis, they're gonna always be, the null is always gonna be, in past it was always gonna be equal to 0 or equal to something, equal to whatever someone thought. And now we're gonna do, it's that same thing but with more words. So in this question, we're looking at a bag of M&Ms, and they asked the distributor, they asked the M&M company, whatever, how much of each color should be in each bag. And so this is what they said. They said it based on percentages with the colors, but they don't actually count up the colors. That's how they make it in the population, and basically is those 13. And so what we did is we bought a bag of M&Ms and we counted it out to see if it really is, or how close it is to these percentages that the manufacturer said it should be. So our null hypothesis is this first one, that the colors are the same as the manufacturer says, and then our alternative is that they're not the same. So now we have a column. Frequency is our observation. So we bought this bag of M&Ms, or colored candies, I guess is what it says, and we counted out how much was in the bags, and that is our frequency column. And then we have to fill in the expected. And so how we're going to do that is we are going to add up the frequency to see, we need a total number of M&Ms in our bag before we can figure out how many of each color is supposed to be. So we're just going to add up these numbers in the frequency. Oops. So this is our total right here. 1, 2, 3, 4, 5, 6. Do we still have 6 colors? 1, 2, 3, 4, 5, 6. Okay, good. So now what I'm going to do is I'm going to go into StatCrunch, and I'm going to type in our data. For some reason, so we click on this, and it doesn't let us change it to here. So I'm just going to put this data into StatCrunch. And I'm now putting in the frequency, so I'm going to actually say observed so that I don't get confused. That needs to be 56. Okay, and so now we're going to pull this up, and I'm just going to put the total off to the side, not in any of these columns, just so that I don't forget it. That's just for my notes. We're not going to use that. If you want to write it down on a piece of paper, you can do that as well. Okay, so now what we're going to do is I'm going to times our total number by the percentages that it's supposed to be. So it has the percentages right here for me, the claimed proportion. And so that is what I'm going to do. So our total times 0.13, there should be, and you keep the decimals, there should be somewhere around 50.83 brown M&Ms. And now we're doing yellow. And now we're doing red. And now we're doing blue. And now we'll do orange. Now we're doing green. So we type in our total and times it by the percentage. Okay, and these are expected. So now we need to type this all in here. And the reason why I put it in StatCrunch first is because we're going to end up using it. So I found it easiest to do it this way, of writing it down in StatCrunch. One of my answers is incorrect. Do they all match? Oh, this is supposed to be 8.4. Oh, 1 decimal, guys. 1 decimal. Okay, so now when we find the test statistic, in other problems, you're going to be able to click on, and it'll usually give you your expected and observed, both. You don't have to find it yourself, and then you click on, the blue little boxes that then lets you open it up in StatCrunch. But we typed it in StatCrunch because we need the data here. And so to find the test statistic, this is like what we've been doing in the past, but before it was represented as a t with a sub-zero, and now we're doing an x squared sub-zero. And the x squared is the chi-square. So if you guys remember from, I think it was the 3rd test when we were dealing with those different types of calculators, and it was this x squared. Anyways, so that comes from the same thing. So we're going to go to stat, and we're going to go to goodness of fit, because that's what we're talking about, in the chi-square test. And then our observed that I labeled are expected. So the observed is the frequency, and the expected is what we calculated based on these percentages that the manufacturer says. And then we'll click compute. And this chi-square number right here, that's right next to the p-value, that is our test statistic that it's asking us about. And then the p-value is the p-value like it has been, and it is very small. Same thing, our level of significance, same rules apply. If the p-value is less than the level of significance, like it is here, we're gonna reject the null. But if the p-value is greater than, then we're going to accept, or not, we're gonna do not reject. So in this case, we're rejecting the null hypothesis. And when we reject the null, it's because there is sufficient evidence that the distribution of colors is not the same as stated by the manufacturer. All right, and so that's it for question 5.